Hi everyone, how are you guys doing? First of all, let me welcome you guys to the Unacademy JEE English. This, as you know, is a brand new channel where everything is being taught to you completely in English. And today, you joined with us for this quiz on momentum. Okay, so this is the quiz code that you need to put in order to join this quiz. Okay, so how to join this quiz? I hope by now most of you know it. So all you need to do is go to the Unacademy app. All right, like this. Go to the app, then go to plus, then click on test, and here you will have two buttons, or one saying join quiz, one saying host quiz. You go and click on a join quiz button, and when you do that, you will be needed to put in a quiz code, and this is the quiz code that you need to put in to join this quiz. So 913231, that is the code for today's quiz. Okay, so quiz code I'm going to write in the chat also is 913231. So hurry up, join this quiz fast. Okay, so let's get started with the quiz as soon as possible. All right, hurry up. Quiz code is 913231. So hurry up, guys, and join this quiz. Okay. All right, let's quickly join the quiz. So go to your plus Unacademy app, go to the plus section, hit on the test tab button, and then enter this quiz code to join this quiz. And let's quickly join the quiz so that we can get started with it very soon. Okay. All right. So here is the quiz code if you want to join. So hurry up and join quickly. Come on, let's have some participants fast. Okay, people. Oh, by the way, news for you. Now the quiz feature is also available on iPad. Okay, so I know some of you, including me, we have been waiting that when will this quiz feature be available on iPad app. So it is now available on iPad app also. So you can join this quiz using this quiz code 913231. So hurry up and join the quiz fast. All right, still waiting. Hello Rajesh, how are you? So hurry up, people, join this quiz. All right, so we already have one guy who's joined. So hello AP, how are you? So how about others? Let's quickly join this quiz so that we can get started. All right, so I'm going to wait for one more minute, and in one more minute, we will start with the questions. Two of you have already joined. Okay, hurry up. All right, waiting for others. I'll wait for one more minute. Okay. To join fast. All right, so we have three participants now. Great. So we will be starting in within 1 minute then. All right, anybody else who's planning to join the quiz should do that very, very fast. And you can use the quiz code 913231. Okay, that's on your screens right now, right behind me. Okay, right there. Use this code 913231 and join the quiz fast. All right, so why don't we get started? I think we have waited enough, and three people have already joined. So without wasting any of your time, I would like to start with this quiz. All right. So starting the quiz, good luck, guys. And anybody else who wants to join can join in the middle also with the quiz code 913231. Okay. So good luck to you people. And here we go. Okay, so here is your first question. You've been told that a uniform rope of mass m per unit length hangs vertically from a support that the lower end just touches the tabletop. If it is released, then at at a time the length of y of the rope has fallen, the force on the table equivalent to the weight ky of the rope, where find the value of k. Okay, so this is very very simple, though this is a variable mass system, but I don't know if you have solved a problem like this, you should be good to go. Okay, so here is your question. Okay, and there are your options. Option one says one. Option B is two. Option C is three, and option D is 3.5. Okay, so mark your answers quickly. Good evening, Rajesh. How are you? All right. So hurry up, time is almost getting up. All right. The correct answer was three, and two of you guys got this correct. Very nicely done. Okay, moving on to the next one. The next question says the coordinates of the position of particles of masses 7, 4, and 10 kilograms are 1, 5, 3, minus 3, 2, 5, 7, and 3, 3, minus 1 centimeter respectively. You have to find the position coordinates of the system of center of mass of the system. Okay, so very very simple again. So hurry up. Three masses have been given to you, okay, and three masses have position coordinates of 1 comma 5 comma minus 3, 2 comma 5 comma 7, and 3 comma 3 comma minus 1, and their masses are 7, 4, and 10. So let's quickly find the coordinates of the center of mass. Okay, so let's see. So here are your options, by the way. Okay, I hope everybody can see the options. All right, so amazing, 100% correct answers. Very well done, guys. All right, well done. Moving on to the next question then. So you've been told that a ball has a velocity v. A ball with a velocity v hits a massive wall moving towards the ball with a velocity u. An elastic impact lasts for a time. So time delta t, I think delta t is missing. So yeah, delta t is right here at this corner. Okay, so here you are. delta T. So you've been told that an elastic impact lasts for a time delta T. Then the average elastic force acting on the ball is. Okay, this should be super easy. Okay. So these are your options. So average force has been asked of you, and average elastic force. Okay, so maybe I can make these options like this. So that might be a little better. Yeah, I hope you can see all the options now. Okay. So here are your options. First one says the average force acting on the ball is m plus v by 2 v by delta t. Okay, yeah, maybe that is slightly better. All right, great, well done. Hello Mahi ji, how are you? Let's see the next question. Now the next question says a 2000 kg rocket in free space expels 0.5 kg of gas per second exhaust velocity at 400 meter per second for 5 seconds. So what is the increase in speed of the rocket in this time? Okay, so find this. Okay, so again, this is a variable mass system, which is not technically in the IIT JEE syllabus anymore. But yeah, I know. Students like questions on this. Okay, so this is very simple though. Okay, and you shouldn't have too much trouble if you know how to calculate the thrust due to variable mass system. Okay, hurry up and let's see. Okay, so this is momentum conservation in any case. So which you should be able to solve in any case. All right, let's see how many of you get this correct. All right. Okay, well done, guys. Okay, let's move on and let's see the next question. The next question says a bomb at rest explodes into two parts of mass m1 and m2 if the momentums of the two parts are p1 and p2 and their kinetic energy will be in the ratio of. So what will be the ratio of the kinetic energies? So what do you know about the momentums? Okay, the magnitudes of the momentums. See, the bomb was initially at rest, so that should tell you about how the two momentums would be related. If you can find the two momentums, you know how momentums are related to kinetic energy. So that is what you need to do. Okay, all right. So let's get this done quickly. Hmm. All right, I'm almost getting up. Last 20 seconds. So just use the fact that the momentums you should know that initially the bomb was at rest. So that should tell you something about the momentums and should know the relation between the momentum and the kinetic energy. If you use all that information, then this should be easy. All right. So well done, well done. 100%. You guys gave the correct answer. Very well done. All right. So move. Let's move on to the next one. So this is going great. All right. Now you've been asked that a body of mass small m collides against a wall with a speed u and rebounds with the same speed. Its change in momentum is so okay. This is super simple. This is super easy. Should all get this one correct. Okay. Okay, so Dr. Gadgetology says will NEET 2021 postponed. Maharashtra and Gujarat board exams are in May. So Dr. Gadgetology, I am not the best person to comment on that. So keep following the news, and trust me, I'll also come to know when it comes in news. There is no point speculating much, because last time also people were speculating that the board exams will get, or the JEE would get postponed, but that did not happen. Okay, so it's best to be prepared for the worst and keep following the news. Okay, that is all I can say, guys. It doesn't really matter what I say, okay, because I may say something, and what if that doesn't happen? Then you might end up blaming me. Sir said this and that did not happen. Since I have no authority in that decision, so it's better that I do not comment on that. Okay. Okay, so this was easy. Oh, surprisingly, one of you got this wrong also. Okay, no worries. No worries. Pay better attention to your questions. This is super easy. All of you should have gotten this correct. Okay, now the center of mass of two particles lies A on the line perpendicular to the line joining the particles, B on a line on a point outside the line joining the two particles, C on the line joining the two particles, D none of the above. So this is again very easy. This I had also showed in my lectures. Okay, so this you should be getting right. All right, hurry up. Last 30 seconds left. All right, super easy problem. I think this, if you remember the lectures, should not be a problem. Okay, if you paid attention in the lectures, if you watch the lectures properly, it shouldn't be a problem. All right, time is up. So very well done. 100% of you got the right answer. Very well done. Okay, so three more questions to go. So if people want to catch up with Ankit Pandey, so you'll have to put in some effort. Okay, five identical elastic balls are so suspended with strings of equal lengths in a row that the distances between adjacent balls is very, very small. If the extreme right ball is moved outside and released. So this you must have seen also. It's a very, very common thing. One on extreme left ball will bounce off. Two extreme left balls will bounce off. Three extreme left balls will bounce off. All the left four balls will bounce off. Okay, so hurry up. So there is 45 seconds still for this. Okay, try and get this correct. This is again very, very easy. Nothing much here. So if you release one ball on the right and leave it, when it goes and hits the wrist, what will happen? Will one ball at the extreme left move? Will two balls move? Three balls move? Or all four will move? Okay, last 10 seconds left. So if you haven't answered this, hurry up. Yes, very well done. I did expect all you guys to get this correct. All right. Great going, people. Two more questions to go. Good luck. Let's get them right. So you've been told a ball of mass m is dropped, approaches a wall of mass capital M, which is much greater than small m, with a speed of 4 meter per second along the normal to the wall. Now the speed of the wall is 1 meter per second towards the ball. The speed of the ball after an elastic collision with the ball will be. So here are your options. So A 5 meter away from the wall. Okay. B 9 meter away from the wall. C 3 meter away from the wall, or is it D 6 meter away from the wall? Remember, this is an elastic collision. Okay. And the wall is very massive. The wall is very massive. What do you know about that? Okay, so last 15 seconds left. So hurry up and mark your answers very, very quick. Okay, time almost getting up. Very well done. All of you got this correct. Yes, the correct answer was, in fact, D. Nicely done. All right. So let's move on to the last question then. So this says, in a 1D collision of two particles, velocities are interchanged when A, the collision is elastic and masses are equal. So this was told to you. B, if the collision is inelastic but masses are unequal, you have to select the correct alternative. So only A says only one is correct, B says only two is correct, C says both one and two are correct, and D says both one and two are wrong. So in which case are the velocities exchanged? So statement A says if the collision is elastic and the two masses are equal, and option B says uh, statement number two says that if the collision is inelastic but the masses are unequal. So here are your options. A is only one is correct. B says only two is correct. Option C says both one and two are correct, and option D says both one and two are wrong. So very very simple problem. Again, if you followed the lectures, this was specifically told to you, and the result was told to you. That is a must remember, very very important result. Okay, so hurry up. Last 10 seconds left now. Okay, so very well done. 67% of you gave the right answer, which is nice. So congratulations, Ankit. You finished the quiz in the top place. All right, very well done. Congratulations. Okay. Now let's take a quick look over the solutions. So in the first case, you've been told that this is the case. Okay, so you know you have to apply the thrust force is dm by dt times your v relative. So what will be dm by dt? So dm by dt times v relative. Okay, so the descending part will free fall. Yes, absolutely. The rate at which momentum is transferred to the table is d by dt of mv square, which is correct. All right. So that is how you would have done this. Then for the second one, this is super easy. This is simple formula application. Okay, you have to apply the form that r vector equals m1 r1 vector plus m2 r2 vector plus m3 r3 vector over m1 plus m2 plus m3. The third one, you already know that the average force is nothing but the total change in momentum over total time. The fourth one, again, you should have applied just momentum conservation. Okay, the thrust force is constant, which is given as dm by dt times u relative. This would be equal to m times dv by dt. Okay, so here m has been considered to be constant. Okay, so otherwise you get your answer in log. So here I think they have ignored in the question that the m would vary. Otherwise, when you're integrating, this m would also come down, and you would have had to integrate for that also. Again, this is also very very simple. If you knew the relation between kinetic energies, it is p square over 2m. Okay, so that is also written wrong. So k would be equal to p square over 2m. So since p's are same, so the ratio, when you find the ratio, it would be simply m2 over m1. Okay. Now again, this question, this was super simple. The change in momentum was 2mu initially minus final. That's about it. And this also was a fact-based question. The CM does lie on the line joining the two masses. In fact, it divides the line into inverse ratio of their masses. This also I told you. Here also, this also you had seen that because of momentum and energy conservation, only the same. All the masses would have exchanged the velocities. Okay, so one would have exchanged it with two, then two would have exchanged it with three, so on, and finally five would have gotten the final velocity. Okay, in question number 9, again, you know that this would be the situation. And since the coefficient of restitution is 1, velocity of approach is 5, velocity of separation also has to be 5, for which the velocity with which the ball moves has to be 6. Okay, and finally, this already had been told to you in class, option 1 is correct. So in elastic collisions, if two masses are equal, then they exchange velocities after the collision. All right. So those are your solutions. So very well done, guys. I think all of you did very well, and especially congratulations to Ankit, who hello Amod, how are you? Who was at the top of the leaderboard finally. All right. So with that, I will take your leave, and I will be back in another, let's say, 8 minutes. So at 4:40, I will start my lecture for the day, which is about class 11 topic, EMI. Okay, today we'll be talking about self-induction. So join me again in another 7, 8 minutes. Okay.